This is problem 4 from week 3 of building construction, and this is actually quite a bit simpler problem than the previous one. Some assumptions you have to make on this problem is that these weights are hanging from wire ropes, which are changed in direction with no loss in force by riding on a pulley. So these red objects here represent frictionless pulleys. And that matters for a couple of reasons. One is that we're able to determine, the tension in this wire rope. If we were to cut this wire rope here and put a fish scale through it, well, the tension is equal to the weight hanging from it, because we don't consider the weight of the wire rope or anything. And because this tension is transmitted undiminished through here, we know that the tension here is 100 pounds. The other thing that works to our advantage here is that the assumption given in the problem is that this angle is equal to this angle. And because of that, really, you could divide this whole problem in half, solve for one side, and double the answer to get the total weight of the body. So let's think about what we know. This angle through the center line is 120, which means that on this side is 60. The complement to that 60-degree angle is going to be this included angle here, 30 degrees. So we have a set of vectors now. We have a horizontal component and a vertical component, and the included angle is 30, and the tension along the hypotenuse is given as 100 pounds. So if you think about the left and right tensions, these are going to cancel out. The horizontal components have to be equal and opposite. If they weren't equal and opposite, the wire rope would just simply adjust itself until they were. So we really don't even need to worry about the adjacent sides here, because A1 and A2 are equal and opposite and not relevant to the problem at hand. This opposite side here, this O2, does matter. And let's think about what we know. Well, what relates opposite and hypotenuse, the two things we know? Well, so, ka, toa. So the thing that relates opposite and hypotenuse is the sine function. So sine of 30 degrees equals the opposite side over the tension in the wire rope, which is 100. Multiply both sides by 100. 100 times the sine of 30 equals the opposite side force. So let's get that figured out first. 30 sine is 1/2 times 100. The vertical component of the tension in that wire rope is 50 pounds on the right side. So this is 50 pounds, and by virtue of the problem they've given us, this is a simple problem in that this is a mirror image, so the vertical component of this wire rope's got to be 50 pounds. And so the weight of the body here has to equal the sum, right? The sum of all of the forces in the y direction must add to 0. So we have positive 50 on the left side, positive 50 on the right side. We need to add something to that will get us to 0. Well, the thing we add is negative 100, and the negative just indicates the direction of the weight, that the weight is pulling down. So a pretty straightforward problem, but a good illustration of static equilibrium and translational equilibrium.